All right, welcome. This is Chapter 1, Section 2, Phases, Eclipses, and Tides, your PDN. What does revolve mean? This is a review question from your previous PowerPoint slide. So, phases, eclipse, and tides is our topic. Give you a couple more seconds to answer the PDN. Right. Last section we were talking about the motion of the Earth. Today we're talking about the Earth and its relationship with the moon. The motion of the moon. It revolves once around the Earth every 27.3 days. It rotates on its axis also once every 27.3 days. That means that the same side of the moon is always facing the Earth. Some of you might have heard of the phrase dark side of the moon. There is no side of the moon that is always dark. However, there's a side of the moon that we never see from Earth. The only way you ever see it is by sending a satellite up there or sending a person up there. Uh, the, the word for when a moon is always facing the planet it's revolving around is called tidal lock. Our moon is tidally locked to the Earth so that the moon will never, ever, ever point away from the Earth. That one side's always pointed. Um, if you ever get a chance there, you can Google pictures of the far side of the moon, and there are quite a few craters on the other side. That has to do with because it's pointing away from the Earth. Anything that hits the near side of the moon has to pass by Earth's gravity well to strike that side of the moon. So Earth is actually acting like a vacuum cleaner, sucking up any asteroids that might hit the near side of the moon. The far side of the moon is always being struck by satellites. So one moon day is equal to one moon year. A moon year is the amount of time it takes the moon to revolve around the Earth. A moon day is the amount of time it takes the moon to rotate. Remember those differences between rotation and revolution. Rotation is spinning around, revolution is one object moving around a second object. All right. The man on the moon. That is on the near side of the moon. People have been looking at the moon for thousands of years and they've noticed different things. The man on the moon is one of the things that they noticed by looking at it. Um, Other people have looked at the moon and rather than seeing a face, they thought that there were actual seas. The dark parts of the moon are known as seas. We're going to talk more about them a little bit later. Yep, the dark side of the moon. There's no dark side of the moon. There is just a far side of the moon. All right, the phases of the moon. Guys, if you look over here to where my cursor is moving around, oh, you might not be able to see it. The object in the to the right, it's got all the phases of the moon. That's on your notes sheet as well. You need to label all of those. All right, you might want to pause it so that you can label it. I'm going to be talking about the text on the other side. All right, the moon does not produce its own light. It only reflects sunlight. The different shapes of the moon are from the different amounts of sunlight that are striking it. When the moon is full, that means that it's the side that is being completely lit up, the day side of the moon, is shining on the earth. You see a full moon, it actually rises about the same time the sun is setting, and it sets about the same time that the sun is rising. It is out all night long. Now, the opposite side, a new moon, that means that the moon is not exactly between us and the sun, but close to exactly between us and the sun. It's not causing an eclipse. It's just the side of the moon that's out is completely the night side of the moon. So we can't see a new moon. And it's actually out all day long. The other phases of the moon you may see in the daytime side or the nighttime sky. They have to do with when how much of the moon is shining towards us. A crescent moon is that sickle moon that you guys might have seen in illustrations when you were younger. Usually they have like a kid sitting on the end of it for one of the movie chains. A gibbous moon is a moon that's almost full. It's more than half full, but not all the way full. And actually, the half moons are known as the quarter moons because they count this entire cycle as a lunar cycle. So the half moon is a quarter way through the lunar cycle. Right. All right. I think I talked about everything that's already on here. So let's move on. Oh, we got to talk about the different names for the shadow. There are two types of shadow. There is a umbra and there is a, hold on a second. Let's see. Let me get to the right part. Okay, there are two words for the shadow. The darkest part of the shadow is the umbra. The penumbra is that not quite completely dark shadow. Umbra is the darkest part, penumbra is the lighter part. Two words that have to do um, with the shadow. Oh, wait, that has to do with eclipses. Sorry about that. Yeah, sorry about that. I'm going to back up. That's my mess up. Guys, ignore what I just said. We haven't gotten there yet. All right, this is still about moon phases. We already talked about all this. All right, now we got to get to eclipses. Sorry about that. On your note sheet, it should be the part that says eclipses. All right, an eclipse is when an object in space comes between the sun and a third object. It casts a shadow. There are two types of eclipses that are common here on Earth. One is a solar eclipse, and the other one is a lunar eclipse. Lunar eclipses are much more common. That's when the Earth comes between the moon and the sun. Earth blocks the sunlight from the moon. So you go from seeing a full moon to seeing no moon to seeing a full moon again over the course of about half an hour. It only occurs during a full moon. Lunar eclipses happen somewhere in the world about every 3 to 6 months. Solar eclipses are much more rare. They only occur during the new moon. They happen when the sun gets between the earth the moon gets between the earth and the sun. So the moon actually blocks out the sun. Now, because the moon is so much smaller than the earth, there is only an eclipse on part of the earth. If you're in that small part of the earth that has an eclipse, you see a total solar eclipse where you won't see any of the sun for a very short period of time. They're very rare and people will actually travel to see them. There is going to be a solar eclipse this summer in August, and you're going to be able to see it from the southern United States. It's going to be the last one for a couple of decades that you can see from the United States. So I'm actually thinking about traveling there. I know a lot of people that are traveling down south just so that they can see the solar eclipse. Um, if you're not quite in the part that is complete shadow from the moon, you may be in part that there's a partial eclipse. That would mean that the sun would dim a little bit. It won't get completely dark, but it'll dim a little bit, and it might be hard to see for just a short period of time. These eclipses only occur during a new moon. All right, umbra and penumbra. These have to do with eclipses. Oh, guys, draw the Earth, Sun, and Moon, umbra and penumbra, lined up in a solar eclipse. This picture right here is what you can draw for the different parts. Penumbra is the part that is partially shaded. Umbra is the part that's completely shaded. So in the penumbra, you would have a partial solar eclipse. In the umbra, you would have a total solar eclipse. Okay. That has to do with the large size of the sun and the small size of the moon and the large size of the earth comparatively. All right. The penumbra, part shadow, partial eclipse. The umbra is a total shadow. You guys can always pause this. I'm going to continue on. All right. Now, for a lunar eclipse, you're going to have to draw this on the back of your page. You're going to have to draw the Earth, Moon, and Sun in a lunar eclipse. Now, there's um, on this one, the Earth generally shades out all of the Moon. Every once in a while, the Moon has a partial eclipse, but it's not very often. Usually, the Moon is in a total eclipse, but every once in a while, because the Moon kind of wobbles in its orbit a little bit, and it's really not this close to the Earth. It's actually much, much further out. It will occasionally be in the penumbra rather than the umbra, so it'll have a partial eclipse. But because the Earth is so much larger, its umbra is much larger. All right, so you are going to have to draw this. You're going to have to draw this on the back, drawing a lunar eclipse. You're actually going to have to draw these on your quiz. So, or identify which one it is on your quiz. So you need to know these two different diagrams. All right. This is what a lunar eclipse will look like from Earth. In a total lunar eclipse, it actually isn't that you can't see it at all, because a total lunar eclipse, the moon is still going to light up because it'll have Earth light that's shining on it. It'll have light that's reflected from the Earth that'll reflect back on the moon. It's actually kind of neat. All right, tides. Tides are caused by the interaction of the Earth and the moon. The moon and the Earth both have gravity, and the moon has enough gravity that it actually acts on the Earth and it pulls on the Earth. Now, it's not enough for us to feel it as individuals. It's not like when the moon's in the sky, you'll feel it pulling you towards it. No, but it is enough to act on the water. If you've ever been to the beach, you've noticed that there's high tide and low tide, where the water will come up on shore further and then it'll pull away a little bit. That has to do with the action of the moon on the water of the ocean. There are actually two high tides. There's a high tide that's pointed towards the moon, and at the same time, away from the moon, there is a second high tide. The high tide towards the moon is caused by the moon's gravitational pull. The high tide away is caused by centrifugal force. You guys might be familiar with centrifugal force. If you ever seen somebody take a bucket of water and spin it around, they can actually keep all the water in the bucket if they're spinning that bucket fast enough. Centrifugal force is what's keeping it inside. It's actually has to do with inertia. So, tides rise and fall of water. It's caused mainly by the moon's gravity. And any time there are two places with high tides and two places with low tides, one is pointed towards the moon, the other is away. There will always be low tides that are on the opposite, neither completely away or completely towards the moon. All right. Now, the next one is neap tides and high tides. Neap tides have to do with the moon. The sun. When the sun, the moon, and the earth are at 90-degree angles, that's supposed to be 90-degree over there. It's not 900, it's 90-degree. When they're at a 90-degree angle, what'll end up happening is that the tide will not be quite as high. When they when the tide is not quite as high, that won't be quite as deep for places that have shallow water. Spring tides are actually important because there are some places that ships can only go when there is a spring high tide. If there is a place that has low water, some ships with deep hulls that go deep underwater can only go into these areas, go into some harbors when there is a spring tide. So spring tides and neap tides are actually important for sailors. So a neap tide is when the sun, the earth, and the moon are at low angles. That means that the sun is kind of making the low tide a little bit higher. And because the low tide's a little bit higher, the high tide won't be quite as high. When the moon is either pointed towards the sun or completely away from the sun, then the high tide is going to be extra high and the low tides are going to be extra low. So you need to draw on your paper there the sun, the moon, and the earth at a high tide and a neap tide. Let's see. I think that's everything. All right, here's more pictures with the neap tide, This might be easier for you guys to draw. There's two different types of spring tides. One is when it's either way. For a spring tide, the sun, the moon, and the earth are lined up, but it can either be during a full moon or during a new moon. All right, guys, if you have any questions, don't be afraid to ask me. I'll be wandering around the classroom while you're working on this. Um, I hope you guys enjoy this. Sorry for my couple of mess ups there, but we'll see how this keeps going. Hopefully, I can keep doing this.